Okay, so we're going to talk about dilations right now. A dilation with a geometric figure is a type of transformation. It is non-rigid. It will maintain or keep the shape of the figure, but it will change the size. So it will either grow the size, so a stretch, it will expand, get bigger, or it will shrink, it will get smaller. So if it gets larger, that's called a stretch. If it gets smaller, it's called a reduction or a shrink. So basically, we start off with a shape like this, and then a stretch will look something like that. Now we're going to when we dilate it, we dilate it with respect to a point, and so depending on where the point is, that will determine what the dilation looks like. So for instance, this one, it went up like that and it stretched that way. If we had started somewhere in the middle of the triangle, it might look more like that. But the shape would be the same. It won't be turned, but it'll be up like this. It could be to the side. So, but depending on where the point of dilation is. Now this one was dilated with respect to the origin. All of dilations we will be doing will be from the origin. When you dilate it using a constant of dilation. And so what will happen is you will multiply the x coordinate and the y coordinate. Oops, I'm putting the number in by the same constant. So whatever you multiply x by, you'll multiply using the same value, you'll multiply y. Now this one right here was dilated by a factor of 2. So we doubled it. And the coordinates turn out to be exactly double. So 1, this one right here, this is 1, 4. This one will be 2, 8. So over 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. So all of those will be twice the size. Here's another one. This one shrunk. So this one may be harder to see because we've got fractions. So this is 1, 4. When you multiply that by 1/2 or 0.5, we get 0.5. So that coordinate is 0.52. So this half of 4 is 2. So 0.52. This value right here will be half of 4, which is 2. So 1, 2, and then half of 1, which is 0.5. The value up here, oops, this will be right here, will be 1.5, 3.5. So the way we actually go about performing the dilation is like this. So let's say we use this rule, x comma y. So this is our pre-image. Our image, let's go ahead and use 2 as our coefficient of dilation. So we're going to multiply by 2, both the x and the y. So if we look at 1, 4, that becomes 2 times 1 and 2 times 4, which is 2, 8. So we're going to plot that point over 2, up 8, which is right there. And that was C, that will be C prime. Like that. Then A will be 4, 1, 2 times 4, 2 times 1, and we get 8, 2. So over 8, up 2, and that's A prime. And then finally, the last one is 3, 7. So when we do that, 3, 7. 2 times 3, 2 times 7. 2 times 3 is 6. 2 times 7 is 14. And so this point right here, which is B, will turn into B prime, which is 6. So 4, 5, 6, and up 14. So there's 4, 8, 12, 13, 14. So that should be B prime, 6, 14. So when we draw that one out, connect the dots. Now, it should be the same size. And, I mean, not the same size, the same shape. So notice this is going up at the same angle, the same slope as this. This has the same slope as this. And this is going the same direction as that one. It's also, see, there it is. Okay, so this is twice as big as that. That's how you do a dilation.